This is chapter 7, section 7.2, estimating a population mean. Okay, now in this section we are going to estimate a population mean. But in previous section we did about population proportion. Now we are going to do some estimations about population mean. Under that we have two parts. First part is when sigma known. Second part is when sigma unknown. What is sigma? Sigma is our population standard deviation. Okay, there are some key concepts in this part. Okay, you know the sample mean x bar is the best point estimate of the population mean mu. Okay, then we should able to use our sample data to construct confidence interval for estimating the value of population mean in two cases. Okay, but in previous section we only have one case, but in here you have to think about of your population standard deviation also. Okay, so if you know your population standard deviation, you have one method, and if you don't know anything about your population standard deviation, you have another method. Okay, then also we should be able to determine the sample size needed to estimate this population mean. Okay, first thing is how can we find confidence interval for mean when we know the value for population standard deviation? That means with sigma known. Okay, so how can you find confidence interval for mean if we know sigma? Then you have to use these two formulas. Actually, this is the formula. If you want to find confidence interval from population mean, it is this the formula. In the left part you will get lower confidence limit. From the right side part you can get the upper confidence limit. Here x by sample mean, E is our margin of error. What is this E? Is that previous formula? No, it's wrong. In here you have new formula. In this formula you don't have like P, Q. Okay, if you have P and Q, it's about population proportion margin of error. But for this margin of error, you have sigma and critical value and n. Okay, so if you know sigma, then if you want to find confidence interval, you have to use this margin of error formula. Okay, please remember that. Then what is the rounding off rule? Okay, you have to round your confidence intervals limits, these two limits, to the same number of decimal places in the sample mean x bar. Okay, please remember that. That means if you have a sample mean with one decimal place, then you have to round your final confidence interval limits also into one decimal place. Also, don't round your margin of error. Okay, please leave more decimals and round at your final answer. Okay, not before final answer. Don't round. Okay, so these are the two formulas you want to find confidence interval for mean when you know the value for population standard deviation. Okay, then yeah, first part is estimating a population mean when sigma known. Sigma is your population standard deviation. Okay, this is the procedure. If you know sigma, then how can we find confidence interval for mu? First thing, you have to make sure that you know your standard deviation for population or not. Okay, if you know your population standard deviation, use this procedure. Otherwise you have to use our next method. Okay, the second step is you have to find your critical value, z critical value for your desired confidence level. You know how to find critical values. We did this one in our last section also. Then Then third part, you have to let your, it is in standard deviation. That's why you have to make sure that you know this or not. If you know sigma, you can use this formula, okay? Otherwise, we have to use our next method. Then the fourth step is this, use this formula to find your confidence limits, okay? Then the last part is you have to round your confidence interval limits according to your rounding off rule. I told you what is our round off rule. It's here, okay? You have to write up to the same number of decimal places as in your sample mean x bar. So this is the procedure. Using some examples, I will show you how to find our confidence interval for mean, population mean, when population standard deviation is known. The first example is this mean weight, okay? Okay, first read the example. In recent decades, the mean weight of men has increased considerably. So we need to update our estimate of the mean, okay? So that boats, aircraft, elevators, and other such devices do not become overloaded. Then we have this information, a sample of 40 men. So what is our sample size? N is 40 and is and the mean weight sample. So we have x bar is found to be 175.55. We have that value. Also, you have to assume that population of weights of men has a standard deviation of sigma. So in this case, we know sigma known. Okay, so you can use these two formulas, okay, this margin of error formula, and plug values in here. Okay, we have four parts. I will show you how to find these values. Okay, first part, what is that? What is the best point estimate of the population mean weight? Okay, so you have to write the best point estimate of the population parameter. Here it's population mean. So the best estimate of the population mean is sample mean. Okay, so it's x bar. Okay, here I already written down that value x bar. That is the answer for first part. Then you have to write what is your x bar. In example, it says a sample of 40 men is taken and the mean weight of the sample is found to sample mean. Okay, in here our sample is 40 men and 175.55. So that is our sample mean. So that is the best point estimate of the population mean. Okay. Then it is our part A, part number 1. Then for second part, you have to calculate the margin of error, E. Okay, you have to find that value. But before that, you have to think something. What? In here, assume the population of weights of men has a standard deviation. Okay, so in here you know the what sigma, that means you know the population standard deviation. Okay, 26. You in here you know the sigma, population standard deviation, that means you know sigma known. Okay, in this case sigma known. Okay, so if you know sigma, you have one margin of error formula. You have to use that one. It is this. Okay, because there is another case. Okay, it is in part 2. If you don't know sigma, you have to use another margin of error formula. But in here, you know the population standard deviation. Okay, you know this, so you have to use this margin of error formula. Okay, here you have sigma here, then square root of n. So use this formula. Okay, now we can substitute values. What is our n? Here it says we have a sample of 40 men. So our n is 40. Then what is
the confidence level, it's 95% confidence level. Okay, our confidence level is 95%. So remember, I told you how to find critical values, or if you want, you can remember the important critical values. I told you if it's 95%, what will be the critical value? It's 1.96. Okay, if you don't know how to get this one, read slide number 9. Okay, I got this value from slide number 9. Okay, so if you want to understand how to get this one, go to that slide and read that slide number. Okay, so we got our critical value. Then what is our standard deviation, population standard deviation? It's 26. Then divide by square root of n. Our n is sample size, then take the square root. Okay, this is the thing you want to find. Okay, what is the value of this part? This is our margin of error, so please don't round at this position. Okay, so write at least up to 6 decimal points, but I will write up to 6. Okay, 6 or 7, 8, any number of decimal places, not like 20, 40. At least write up to 6 or 7 decimal places. Okay, so the answer is 8.0574835. I wrote up to 7 decimal places. Okay, now this is my margin of error. It's our part 2. Now what is our third part?
Okay, third part is this.
Now, third part is construct a 95% confidence interval for mu. Okay, so what is the formula for constructing confidence interval? This is the formula. Okay, x bar minus e, then mu less than x bar plus e. Okay, here if you know x bar and e, substitute values here, then you can find the lower confidence limit and upper confidence limit for you. Okay, I will substitute values here. What is our x bar? It's 175.55 minus our margin of error, 8.0574835 less than mu less than x bar is again same value, 175.55. Here it's plus, again margin of error, 8.0574835. Okay, then what is our lower confidence limit? It's 0.9. Here I write up to 2 decimal places. Why? Because I told you you have to round confidence interval limits to the same number of decimal places in the sample mean. Okay, in our sample mean we have 2 decimal places. So in the final answer also, you have to write your confidence limits up to 2 decimal places. Okay, then what is our upper confidence interval? It is 186. Okay, here 167.49, here 183.61. This is my confidence interval. This is the answer for third part. Okay, here I wrote up to 2 decimals. Why? In our sample mean also we have up to 2 decimal places. Then final part, you don't need to do any calculation. Okay, what do the results suggest about the mean weight of 166.3 pounds that was used to determine the safe passenger capacity of water vessels in 1960. In that time, they thought mean weight is 166.3. Actually, it is that our value, because the population mean should be in between these two values, 6.3. Okay, so what we can suggest, we can say it is not possible at that now, okay, to have mean weight of 166.3. Why? Because it is not in our range. Okay, so what is the answer? It is not possible. It is not possible now. Okay.
Okay, it is all about this example. Slide number 27. Now I will show you how to find values for this example, ages of automobiles. In here we have 50 adults, and we got that the mean age of a person's primary vehicle is 5.6, and you have to assume the standard deviation of the population is 0.8. That means in this case we know our population standard deviation, we know sigma. Okay, we'll see how can we do this example.
Okay, the example is ages of automobiles. The first part is what is the best point estimate of the population mean? You know what is that? The best estimate of the population mean is definitely sample mean. Okay, so next thing we can write what is our sample mean. Read the question, read the example again. A survey of 50 adults, okay, found that the mean age of a person's primary vehicle is 5.6 years. Okay, that is our mean age. So that means that is our sample mean. Okay, so that is the answer for first part. Now second part, it is calculate the margin of error E. Okay, you have to calculate E. To find E, you need what? N, critical value, and standard deviation. First, tell me, do you know population standard deviation? Yes. Why? It says assume the standard deviation of the population. So sigma known is 0.8. In this case, we know sigma. Okay, sigma known case. This is a sigma known case, and our sample size is 50 adults. So it's 50. Also, we have what? 99% confidence level. Okay, the confidence level is 99. Okay, so we have all the information. Now you have to use the formula. In this case, you know sigma. If you know sigma, you have to use this margin of error formula. Okay, if you don't know sigma, we have to use another one. I will tell it in next part. Okay, not this part. This is part number 1, sigma known. Part 2 is sigma unknown. Okay, now we know sigma, so use this formula. Okay, now what is the critical value? If we have 99% confidence level, we did this one in slide number 10. Okay, so I will not do it again. The critical value for 99% confidence level is 2.575. Okay, and fine, but don't waste your time. Please remember and just plug here. Then what is sigma? It's 0.8. What is n? It's 50. Take the square root. Then what is our margin of error? It's 0.291328. Okay, I have written not to 6 decimal places. Now this is my margin of error. It's for second part. Now third part is construct a 99% confidence interval. Okay, so we need 99%. Yes, because our confidence level is 99. So this is the formula. Okay, for constructing confidence intervals. X bar plus E. Okay, we know what is our X bar. It's 5.6 minus what is our margin of error? 0.291328 less than mu less than again x bar is 5.6 plus margin of error is 0.291328. In original value, like the sample mean, we have one decimal place. So in here also you have to write your confidence limits up to one decimal place. Okay, so here it's 5.3 less than mu less than 5.9, because in your sample mean we have answer with up to one decimal. So this is my final answer. This is my confidence interval for 99% confidence level. Okay, so we can say our population mean is lie within 5.3 and 5.9. Okay, so we cannot say exact value for population mean, but we can say at least like this way, our population mean can be lie within these two values. Okay, so this is the answer for third part. Okay, this is slide number 28. Okay, now, okay, that's all about.
Okay, that's all about this example. Slide number 28, ages of automobiles. Okay, now you know how to find confidence interval if you know the population standard deviation. Okay, now next one is, okay, another part, new part. Okay, now how can we find sample size for estimating mu? Okay, in here, this is the formula you have to use if you want to find what sample size. So if you want to find n, and if you know your population standard deviation, critical value and margin of error, substitute values here, then you can find the corresponding sample size. In here, please remember you have a rounding off rule like in previous section 7.1 also we did the same thing. Here it's a sample size, so you have to write it as a whole number, okay, because it's a sample size. So you can't write sample size using decimals. So always round up to next whole number. Okay, you can have any decimal value, but don't need to think about your value of your decimal part. Just round up to next whole, the next larger whole number. Okay, to the next larger whole number. Okay, okay, actually I will skip this slide. Okay, we don't need this slide. It's about some range rule of thumb. We don't want to need this one, so ignore this slide. Okay, slide number 30, we don't need this slide. Okay, now next, this slide is slide number 31. We have a nice example for finding sample size. The example is IQ scores. I will show you how to find the sample size, okay, for this one.
Okay, this is the example for finding sample size. First read the example carefully. It's about IQ scores. Then write down all the necessary information, okay, to find our sample size. First write down the formula. No. First write down the information, okay. In here, you want to find how many statistics students must be randomly selected. That is the question for IQ test. If we want 95% confidence, so what is our confidence level? It's 95. Okay, the confidence level is 95. Then confidence that the sample mean is within 3 IQ point of the population mean. Can you see? It says sample mean should be within 3 IQ points of the population mean. So that is the difference between sample mean and population mean. I told you what is our margin of error, the difference between the population mean and sample mean. Okay, so it is margin of error. Here it says the difference between population mean and sample mean is 3 points. So our margin of error is 3. Here it's E, margin of error. Then next thing, okay, what? Assume the population standard deviation. So you know sigma, okay? Sigma means population standard deviation, it's 15. Okay, we have all the information. Now write the formula first. How can you find sample size? This is the formula, okay, critical value times sigma divided by E. Then you have to square whole value. Please note down, okay? Here you have square, but you have to square whole thing. Okay, now you have everything, so we can substitute. You know what is the critical value if we have 95% confidence level. Remember, I told you, if it's 95, it's slide number 9, it should be 1.9. Is 15. Then what is our square of whole value? The value, and you see, this is in previous section an integer value, okay, but here you have decimals, so you have to round. But please remember, if it's about sample size, you have to round up. Always round up to next whole number, okay? Don't round down. Normally you can see, if it's, you can think if it's this, it should be 96. No, it's not wrong for sample size, okay? If it's normal algebra, you have to write 96, but here you have to find sample size. If it's about sample size, always round up to next whole number, okay? So this is our final answer. So we need at least 97 students to get this get this confidence interval and this error and everything, okay? At least we need this much of students, okay, to get all these values, okay? Okay.
Okay, that's all about this example. Yes. Yeah, now you know how to find sample size if we have population standard deviation, margin of error, and critical value. Okay.